Welcome. My name is Cody Davis, and welcome to our Maze Environmental webinar, where we will discuss our technology that allows producers to eliminate their flaring. I would like everyone to know, for our privacy policy reasons, this meeting is being recorded. And at the end of the meeting, we will email it around along with the pitch deck presentation we have to those who have registered and post it on our website. Today, we'll be showcasing our presentation prepared for the Texas Oil and Gas Association Energy Elevated Conference, where last week Maze was awarded Most Innovative Technology by representatives from Halliburton Labs for what we're about to present to you here today. Throughout the webinar, you can ask questions through your interface at the top with the Q&A button, and we will be answering questions at the end. With that, let's begin with some introductions. We're going to start with our CEO, Brooks Pierce, go to our engineer, Craig Fite, and finish it off with Keith out in the Permian. Brooks, do you want to introduce yourself?
Absolutely. Good morning, Cody. Nice intro. My name is Brooks Pierce. I'm the CEO and founder of Maze. We are working in the oil and gas industry, and not only in Texas, but I'm over here in the Middle East currently working with the client. We're a vertically integrated company that takes it from wellhead to design to manufacturing to installation. And that's my intro. I'm going to take it off to Craig.
Hi, everyone. I'm Craig Fite, the lead process engineer for Maze Environmental. Nice to meet everyone.
Perfect. Does that leave me next? I'm Keith Stelter. I'm out here in the Permian right now, and I'm the vice president of sales, and it's my job to help Cody get the message out to everybody that there's alternatives out there that you may not be aware of to get rid of your emissions and up your production.
And Keith, while you're out there, real quick, let's tell everyone about your cleanup.
Yeah, started it a little bit earlier this year. Got whether you're familiar in the Permian or not, there's a little bit of a trash problem that people speak about online. And instead of complaining, it's in the name, Maze Environmental. Let's do something a little bit good for this earth. Like Brooks said in that video, we're all breathing the same air and living in the same land. So every month, been getting folks together and picking up a little bit of trash bit by bit, and it's caught on. We've done some cleanups. We've shut down lanes on I-20, and the last one we got approached by Coca-Cola and the Special Olympics Committee to help clean up secondary highway 191 between Midland and Odessa, and we had over 120 people show up, volunteers, and we picked up 460 bags of trash, and we were able to make 191 just a little bit better place for the athletes to be traveling on, and as well as the torch run. I think, believe it or not, I think a bit of it goes on that highway. So today it's a little bit better than it was yesterday.
We got a little video to show you real quick before we go into our presentation that we're very proud of Keith for. Here we go. All right, so let me kick this off with the first few slides. So basically what we are is a EPCM company that basically takes you everything from order to delivery to installation to maintenance. But the main reason why we're on here is our technology that we have patented and tested over the last couple of years. And what we have done, is if you take all the flaring locations across Texas, it looks something like this, which everyone can recognize the different basins there. But this attributes to something about 6 billion cubic meters or 11.2 million metric tons of CO2 or equivalent in just 2023 alone. And what Maze is able to do is, if I could press a button and install Maze at every location across Texas, it would take Texas from this down to this, and that is a significant impact on getting to a much brighter and cleaner future here. Craig, do you want to kind of hand it off to you, and you can start the engineering, the next few engineering slides for us?
Yeah, absolutely. Thanks, Cody. So we started this technology to help operators reduce their tank emissions, and we've been able to pilot this technology across a few sites already. We started this technology and implementing it in early 2021, and we've had a lot of progress since then. We've realized that this technology can help a lot of different areas, and instead of just reducing your flaring, but can also help you recover a lot of your lost production that a lot of people are sitting out via tank catches or bidding and flaring. And so with that lost energy, like Brooks was mentioning in this video, it's the more that I study it, the more that I realize it's a lot of energy that's getting lost. And instead of losing it, we try to capture that and put that back into sellable profit, such as your oil or your gas pipeline. And one of the other benefits that comes with this technology and reducing your flaring emissions is lower operating conditions. So we all know that safety is first priority when it comes to these facilities, and we keep the operator in mind when doing so. So we lower your operating and reservoir pressures and make it a little bit safer out there, and also get rid of your flaring. So part of what I do is I help with the HISA simulations. Whenever we start meeting with a client, basically we'll gather data from them. We'll do a site visit. I'll gather process flow conditions and operating conditions and show you exactly what your facility is operating like today as we talk. And we call that the base case. And then I will implement our technology to the simulations and run a maze case, essentially. So we'll showcase the two different cases, how you're currently operating and some of the areas that we can help with, whether it's trying to recover lost hydrocarbons or reducing flaring emissions. So here on the screen, you can see one of our technology showcases that we did in the Permian Basin. This was on a 10,000 barrel a day case. So on the base case, our plant was flaring 181 MCFD of gas a day. And with our technology showcased in the Maze case, highlighted in green with our Maze oil stabilizer, we were able to reduce that down 100% to reach 0 MCF. And with that also came an uplift of 2.75% of oil production. And when we say swell, we basically mean a decrease of oil shrinkage. As we all know, through the oil conditioning process, there's going to be some shrinkage. So we decrease that shrinkage. Usually it's 6 or 7% shrinkage across your oil conditioning process. We would, in this case, we took it down almost 3% and recovered an extra 248 barrels a day. Now we realized that this wasn't best fit for everybody out there. Everyone essentially is doing the same thing, trying to produce oil, but they have different site setups, whether it's an old site or a new site. So we wanted to develop this technology a little bit further to be able to be implemented basically anywhere. So we developed another system, which we're calling the Maze Vapor and Liquid Recovery Tower, the VLRT. And essentially what this system is an identical setup to a traditional vapor recovery tower. It looks the same and operates the same. It goes in the same placement. It's operator friendly, as it's controlled the same way a normal VRT is, except you get the benefits of the Maze system. It's 90% more effective than a traditional VRT, and you can still decrease your oil shrinkage. We saw cases from 0.5% up to 5% spill. And again, with this operating the same way as a VRT, it's zero energy input, no motors or compressors needed. And so you could see the two different tables here, how the outputs come out with oil reduction, oil tank emissions reduction, and oil swell between the two systems, the Maze VLRT and the Maze tower system, which will get you full stabilization. Now, our tower is not based off of retention like a normal VRT is. What our system is designed around is fractionation and absorption. And so you're not needing the same kind of retention time that a VRT does, which, some people design a VRT to have retention times of 5 up to 30 minutes. Our technology is actually not based around retention. So you can implement a much smaller tower. So traditional tower sizing, where you may, for that 10,000 barrel a day case, you would set a 60-inch tower. In our case, we would be only setting a 30-inch tower. So there's cost savings and CO2 emissions reductions from the steel mill of having to not have much steel, not have to build a bigger tower. We optimize the sizing of the tower a lot better. Now, another benefit of our technology is, since we're moving this oil conditioning process upstream of your tank storage, we're actually stabilizing your crude in our system to where wherever you were to take it after that, it would be stabilized and meet your pipeline specs, whether you're trying to meet 7 RVP or you can go all the way up to 10 RVP. We have stabilized crude on the outlet of our process. So that helps you develop technology to go tankless and no need for tank storage. A lot of people rely on their tanks to get that last little bit of oil stabilization so you can sell it down a pipeline for safety protocols. And so we're able to bypass your tanks directly and go straight to the oil cells line and have 100% emissions reduction when it comes to oil tank storage. Now, we've done this, like I was saying, at a few different pilot locations. For this analysis, we went out and we developed a whole field for a client, and basically we're installing stabilization units on these production facilities, ranging from 3,000 barrel a day all the way up to 25,000 barrel a day facilities. And we're kind of grouping together and showcasing the elimination of GHG emissions that we're able to get in just a short amount of time. So, we were, as we were building these facilities, in the first 9 months, we were able to see a 98% reduction across the field with their emissions eliminated, which calculated up to almost 10,000 metric tons of CO2 that we were able to save from emitting into the atmosphere. Now, we wanted to take this analysis even further and now look at the second benefit that oil stabilization provides you, which is an uplift in production. So we wanted to look at just what one tower was doing on one location and monitor that. So we set up a pilot location outside of Midland where we ran and operated for 11 months with 99% runtime. And we were able to swell their oil about almost 2% on average across those 11 months, accounting for an uplift of 31,000 barrels of oil. And you can do a quick calculation of what 31,000 barrels of oil at, just call it $65 a barrel. And you can see
Craig, if you're curious, a couple minutes ago, it was at $72.91.
So yeah, even more, 31,000 barrels times $72 a barrel. You can see what we were able to provide this client an uplift.
Using Craig's HISYS models he's pumped out for various clients and how they do their different tests, we got curious, and it's like, well, what would Maze look like if we implemented it across the United States? If I could tomorrow wave a wand and do it in, up to the 2030 goal of ending zero routine flaring. And we managed to get a hold of the data of how much we flare in the United States. And as you can see, just implementing Maze alone across the United States, if again, the magic wand of everyone had it by 2025. We're eliminating something like 102 million metric tons of CO2 by the end of 2030. And that's not even the cool part. I think it comes back down to we are swelling an additional 385 million barrels of oil from the swell alone. And that's not, when I talk to non-oil interested persons, it's more about, well, what does that mean? Are you taking more oil out of the ground? And Craig, no, you're not. It's the oil you have, you're swelling it up and you're selling more of it. And that's where the cool part comes in with this technology. Brooks or Craig, do you want to go over how we kind of deal with the client and deal with what they want to do in the base case and the maze case?
Yeah, so this goes back to, or I'll let you take it, Brooks.
No, Craig, I was just going to say, go ahead with it. You just got back from a couple of field tours and site visits.
Yeah, so that's generally how we'll start. We'll talk with the client and kind of see where their problems are and what they're trying to do, depending on their location, whether they're, how strict they are with regulations, or, if they're just trying to make a little bit of extra money. I actually just got back from doing a couple site tours out in Midland. So it'll start with gathering process data and to be able to run HISA simulations and showcase the different types of technology. Wherever you're trying to fit on this triangle, whether you're trying to eliminate your emissions or capture a little extra money, trying to recover your hydrocarbons. So, a lot of existing technology are trying to capture your emissions. What we're actually doing is eliminating those emissions to where they're not even coming out of the oil. There's no need to capture all that, and so that's how we're able to get a little bit more extra oil out of it.
And Craig, just to throw in here, you don't have to pick just one of these. Your goals can be just one, and we can maximize it, or it can be all of them. Correct?
That's correct. Yeah. We've kind of, again, it's based on the client's needs, but we tailor same equipment. It would just different operating conditions. We're kind of, whether you want to maximize one, but we target to hit all of these areas.
Can I add just a little bit of something there? Is also when we're doing these facility runs downs, something I talk to the operators about is, because of our background and experience in production and facilities, we don't just look at what we're doing, we look at everything that they're doing on location. So any chance or opportunity we have for them to lower horsepower on pumps, or lower horsepower, or drop horsepower on VRUs to take power down off the grid, that's something that we also look at for them and just kind of bring up as we're going along and running our base cases.
All right, Craig, why don't you sum us up here real quick, and we'll look at some of the technology being developed right now for one of our clients here in a second.
Yeah, so like Brooks was mentioning, it's a simple solution. We make it easier for the operators and for these oil companies to implement our technology and give them, real solutions for their issues. Ranging from eliminating emissions all the way up to 100% to improving their safety with reduction in operating pressures and reservoir pressures. And we understand that it takes a little bit of money to make some money, and that's where we kind of prioritize our return on investment. Where the increase of production revenue kind of helps you recover those costs that you would have to spend on implementing some of this technology and operating, and not only that, but improving your ESG score. We know that's a big issue with environmental regulations coming more into play as months progress, and so we kind of fit all of those areas into our technology and help give a real solution.
All right, before we play this video, if you want to ask, we're going to go right into questions when we're done playing the video. And you can use the Q&A button at the top of your interface to type in your question. And let's go ahead and let me stop sharing here so I can show everybody this thing.
All right, so here behind me we have one of our active builds right now that we're doing for a client in the Middle East. This is our maze stabilization tower. It's pretty large here, as you can see, and we're not even done yet. We still have another top section that's going to get bolted on top of it. So what this does is it takes your crude stream. This is actually built to handle 40,000 barrels a day fluid rate. Works on very low pressure, so it strips out all your light ends while keeping the heavy ends in your liquid phase to stabilize your crude and recover some of those heavier hydrocarbons that typically go out the top of the tower and out into your gas phase. Now for our other package unit that we're doing, since this tower does operate at low pressure, we do need a transfer unit. So this is where one of our production packages comes into play here. This is our fluid transfer pump skid. It has a redundant second pump on here, so we go for zero downtime. Now this monitors your fluid rate. It's going to be hooked up to our stabilization unit to always maintain a positive pressure head on our pump and make sure that we have steady and controlled fluid rate throughout our whole process. Now, we typically can do one part of the project, or we do a fully integrated process, whatever our client's needs are for that project. All right, so here behind me, we have another one of our builds that we're doing for our client in the Middle East. What this is a heat and energy exchanging skid. So instead of having to add or subtract energy with coolers and heaters, we use the existing energy that's in one process stream to efficiently transfer it to another process stream. So we're able to heat and cool down our streams with existing energy in our process to try to minimize our carbon footprint.
All right, again, if you wish to ask a question, you can use the Q&A button at the top of the screen and type in your question there. Let me go back to the very end of our presentation here. And just to sum up here as we go into the Q&A, we've been at this for the last 3 years. It's been a long road. This year we have been invited to the World Climate Conference to showcase the technology. That is a big perk for us, and we're excited about that, and that'll be next month. We have a few questions ready to go. First one we have is, and I'll give this to Brooks or Craig here, how much does this cost to buy or rent?
So the range on this for companies, we go from retrofits that could be, as little as, $100,000, and then it goes up to top end depending on what we're doing, and I mean it goes up to $5-10 million. It really depends on the amount of process flow we're doing. For the Permian Basin, one thing we did do, because we've worked in the Permian and Delaware for a long time, so we have 3 different product models. So we can go for a very low cost model that still gets them swell. Then we have a mid-range model, and then we have it to where we can take them tankless. So we generally leave the client with 3 different price ranges, and we just try to achieve the goals that they're going after. If they want swell, if they want emissions, if they want reservoir reduction and pressure, we custom fit it to the client's needs.
Alrighty. We have another question here. Does this work for new facility builds, or can it be retrofitted to fit an existing battery?
So it's easily retrofitted. That is what we're doing a lot on our site visits, especially with all these companies and all the M&As where they're buying up all these different properties. So they kind of have what we call a mixed bag of facilities. We can easily go in there and retrofit, put in some of our smaller towers for older facilities. And the best case scenario and the best ROI is for them to do it from the beginning. So when we implement in the beginning of a new facility, that's when they're really going to get the benefit of it, because they're going to get that IP production and get that swell right off of their first 6 months. So the ROI on this equipment is really easy.
We had someone in the box raise their hand, James Jenkinson, I believe. Here, I can allow your mic if you wanted to ask your question.
Nice one, cheers. I'm on my phone, so I don't think the option for chatting, I can't find the option for sending a question. But thanks so much, guys. Great presentation, and thanks for having me. My question was related to just deployment times on sort of commercial scale projects.
So generally, once how the process works is we start off, say if it's a new client, where Craig was at a new client, we went to a meeting in Midland with Keith, 2 weeks ago. Craig was out on a site visit the next week. It'll spend about 3 weeks gathering oil analysis and gas data. And then once we do that, it's a 3 to 4 week time frame, and we deliver a scope of work. And once we do the scope of work, then it's engagement with the company. And once it's signed off on, that would go into fabrication, which generally takes about 2 months. And then they're ready for install. And that varies, obviously, between the private companies that can move faster than some of the public companies that we're working for, that, it may take 6 months to do an implementation. We're working with a couple of the majors right now. We actually get off this and have another meeting with one of the majors that they want 2 different pilots on. That's probably a 6-month process for some of the majors to get through all of the red tape, but as little as 3 months and up to a year, depending on the company. James,
is there some sort of visual tool, Brooks, like a Gantt chart that shows a couple of different scenarios on that front for different size projects?
Yeah, well, we basically just size the towers. So you could look at something, right. If you're used to diameter, like Craig in the video, that's a large tower for 40,000 barrels of oil a day. And then that would go down to, say, a small 12-inch tower for a client that, so like the visual Cody put up there on the right, what we call the VLRT is the tower on the right. We have one for a 2,000 barrel a day client that's only going to be 12 inches in diameter. So there's not a lot to actually building it. It's more about the process and the documentation, the paperwork, getting signed off with engineering, getting the company itself to get signed off on, and then gathering either our contractors or using their contractors for an implementation. It's really goes case by case on how fast the companies move.
All right, we have
understood.
We have another question that just came in from Camilla. It's, can you expand on the differences with a typical VRT?
So traditional VRT runs off a retention time. We do not. We're more of an absorption tower. So that's why we're able to go tankless. And you see on the screen right here, we have on the left side, we have a split tower that also Craig showed in his video. That's where we can latch onto that, and then we can go tankless right off of it with our pump system. And we're not working off retention time, which is the basis of a VRT.
Right, and it looks like we have one last question, and it's the simplest question of all. So how does it work?
We'll give that one to Craig.
Thanks, Brooks. You kind of went into it with your last answer. It's simple. It's through an absorption and fractionation process, and not retention time. So we're basically creating this environment for the oil crude to pass through to not only stabilize the crude, take off all your methane, demethanizing your crude, but also capturing the heavier hydrocarbons such as your pentanes and octanes. Your C3s and pluses that usually go out the top end and get captured, whether it's a VRU, selling that volume down a gas sales line. That's where your loss of production goes down, or when you're flaring. There's a lot of oil in that stream and a lot of energy that you're losing. And so through our absorption process, we're able to absorb those heavier hydrocarbons back into your oil and stabilize that oil to where it doesn't come out, whether you're going to an atmospheric tank or down a pipeline to midstream gathering. You know, it's stabilized crude, and we, in some cases, are able to actually decrease your VRU horsepower. Because like I said, instead of having that gas stream that comes off filled with heavier hydrocarbons, you know, it's a less amount of volume. We're leaving those heaviers back into oil, and so that's where the benefit of uplift comes into play.
All right, that looks like all the questions we seem to answer. Before we hop off here, we're Hemidrine people. Keith, why don't you pop back on here and tell us when your next cleanup event is?
Well, we're planning it as we speak. We try to do one cleanup a month here, and but October is filled with football games and a lot of other great events, so we might not do it until November here. So stay tuned. I'm very easy to find on LinkedIn and keep everybody informed on that. Want to thank the people that did come on here. Clayton and James and Joseph, all the folks sent some invitations out to. Thanks for coming on here. Joseph's one of the main guys actually that comes out and does some cleanups out there. We have some other great companies from like Civitas and Birch Resources who also come out. Great guys that participate. And I also want to throw out there, just because I am a salesman, we do have 3 great VRUs for sale out there, 300 horsepower. So you never know. Contact us today. You can get a hold of us. Look at the website. All the information's there. Make sure you reach out. And thanks everybody for their time.
All right, just a reminder, this deck and the videos presented will be emailed around for those who registered and available on the website, mazeenvironmental.com, and we wish everyone a good day.
Thank you. Have a good day. Good job, guys.